Hi everyone, my name is Chuxuan. I'm a PhD candidate working with Dan. So I'm glad to be here presenting my work. During the summer, I've been using a hydraulic model called Work Hydro to simulate and calibrate soil moisture. And for the next step, we attempt to use the calibrated soil moisture to facilitate landslide triggering studies. In addition to modeling work, I actually just came back from a field trip to Big Sur of California, during which we visited several landslide sites. So here I show some pictures from a field trip. On the left-hand side is a log dam accompanied by a post-fire debris flow in 2021. And on the right-hand side is a Mud Creek landslide that catastrophically failed in 2017. So in these types of landslide events, soil moisture is usually the key variable. However, the observations of soil moisture are sparse and limited, especially in these topography complex regions and high mountains areas. So that brings me to the idea of using a hydrological model, Work Hydro, to simulate spatial temporally varying soil moisture. And it turns out that Work Hydro can simulate that at quite a high spatial resolution. So here I show two maps. One is before the storm. This is the simulated surface soil moisture by Work Hydro. And in the middle is during the peak of the storm. And in the bottom left here, you can see two blow-up maps of the red box here. So Work Hydro can simulate this greater details in the channel bed, and it can simulate the wetting processes associated with the storm. And on the right-hand side, I show a comparison of the soil moisture time series between the observations and our simulations. And I show two types of simulations. One is the default run in Work Hydro that we didn't do anything to it. And the second one is the calibrated soil moisture. So we apply a calibration into it to improve the soil moisture fidelity of the Work Hydro. And after our calibration, we see that the correlation coefficient increases, the root square error drops, and the KGE value, which is a comprehensive evaluating metric for evaluating model fidelity, also increase. And that's not just shown in one site. On average across 7 sites, the soil moisture fidelity increases by about a quarter, and our calibrated Work Hydro outperforms the satellite soil moisture data SMAP and the other 3, and now that's 2 land surface models when evaluating against the 7 sites. So for the next step, we plan to use this calibrated soil moisture to input into an infinite slope stability model. And that's actually will be done by the CEE department, a team from the CEE department. And hopefully we can use this calibrated soil moisture to facilitate landslide triggering studies in this area. And with that, I would like to thank all of my collaborators from various institutes, and thank you for listening. And I can take any questions you might have.
Great talk. I'm wondering, how important is the location of high or low slope moisture in the slope face itself when you're thinking about failure in the future?
You mean like within the slope, the variability of soil moisture? Yeah, it's actually very important because considering the topography there is quite complex. So if you move down 1 meter of the slope, the soil moisture can be totally different, and hydrological stagnant there to be totally different. So it's very important. So that's the reason why we need to have like a high resolution modeling of the soil moisture itself. And that will change the shear strain, shear stress that's simulated by the infinite slope model.
Thank you.
Thank you. Awesome. Thank you.